In the preceding movie, we coded this capsule object on top of the terrain here in order to move forwards and back and left and right when we press the appropriate keys on the keyboard. For example, if I press the play button on the toolbar here and I press the up key, I can move the capsule forwards. If I press the down key, I can move it back, and I can do the same with the left and the right keys to move the capsule in those directions. But notice the limitations of this method. It only allows me to move forwards and back and left and right on a single plane. So if I move forwards and then the terrain elevates, we actually pass through the terrain. What I want to happen now is for this object, as it moves forwards, to move up and downwards respectively to match the inclination of the terrain. In particular, what I want to happen is I want this object to be vertically offset from the terrain by a specified distance, so that it always maintains a particular distance from the terrain. Now to do this, we're going to go back to our terrain hover script, and we're going to be relying on the functionality of a physics raycast. And what this effectively is going to do is to shoot out an imaginary ray or line or laser from this capsule here downwards into the scene until it intersects or collides with the terrain. At that point, it tells me where the intersection on the terrain occurred. And once I get that intersection, all I need to do is to make sure that this capsule is oriented upwards from that point by a specified distance, which means that every single frame along the way, it's going to be testing for an intersection with this terrain and making sure the capsule is offset from that. So to continue with this code, I'm going to move back down here to the project panel and find the terrain hover script. I'm going to double click on that to open it inside MonoDevelop, and here we're presented with the code that we created in the preceding movie. So I'm going to amend this code now. We have reached this point here where we calculate the position of the object on the horizontal and the vertical axis based on our input. But now we want to calculate the Y position or the vertical position of the object based on its distance from the ground. So I'm going to create a completely new variable at the top of the class here, which is going to indicate the distance from the ground that the object should maintain. So I'm going to choose distance from ground, and I will say initially that that should be 2 meters. So the object should be oriented 2 meters away from the ground. And now we need to use our physics raycast. Now what the raycast is going to do is give us information about the intersection that happens in the scene. To record that information, I need to create a raycast hit structure that temporarily I'm going to call hit. Then in the next line, I'm going to create an if statement to indicate or to ask the question about whether an intersection occurs at all. So I'm going to choose if physics.raycast, and then this is going to accept some parameters. So for example, the 2 parameters that we need are the position, the starting position for the ray that we are going to cast. And for this, I'm just going to use the position of the object. So I'm going to choose this transform.position. And what I'm going to do then is to indicate the direction of the ray in the scene. Now we want to cast the ray downwards to detect whether it intersects with the terrain below. Now downwards simply means the up vector inverted. So I'm going to choose vector 3 dot up, actually not vector 2, beg your pardon, vector 3 dot up, and I'm going to negate that direction to say instead of up, I mean down. And then finally, the final parameter has to tell it where the raycast hit information should be recorded. So I'm going to specify that parameter here for the third parameter, out and hit. So this data will be saved inside the hit structure. Now I'm going to open up the braces here. This code will only happen if an intersection occurs, which it will do so long as the player object stays above the terrain. And here finally, once we reach this point, I want to get information about the intersection that occurred so I can set the Y position of the player object. Now all of that hit information is encoded inside the hit structure. So for example, I can choose hit and then dot, and it gives me a whole range of properties that I can access about the intersection that occurred. For example, I can get information about the point, the actual point in world space, where the intersection occurred with the terrain. I can get information about the normals, the light map coordinates, the texture coordinates, the rigid body that represents the terrain object, all kinds of different things here, including the collider. But right now, I want to use the hit point. So I'm going to be adjusting the Y position of the player object. I'm going to be using the new position object that we created previously to amend the Y value. So I'm going to choose new pos dot Y. The new Y position of the object should equal the hit data, the point, that is the point on the terrain in world space where the intersection occurred. And to that, I'm going to be adding the up vector because I want to position the capsule up from the terrain, the up vector multiplied by the distance from the ground that I want to maintain. So it's going to be the distance from the ground. And because all of this data together represents a complete 3D vector, I'm only interested in the Y value. So I can then use .y to assign that final value to this new pos.y value here. I'm going to press Ctrl S on the keyboard to save that code and move back to Unity here and let this compile. Unity goes ahead and compiles all of that data. If I now press play on the toolbar and I move this object forwards, you'll notice that now it inclines, or rather it raises and it lowers to match the height of the terrain. So we're going up and down, and I can go back and notice it completely matches the terrain. It maintains that distance from the terrain. Now the distance it actually maintains, if I select the capsule or the player object in the scene, you can see it's 2 units. I could of course increase that if I wanted it to maintain a different distance, but notice that it's constantly conforming to the elevation of the terrain. Now that's splendid, but there's just one main ingredient missing from this project, and we're going to look at what that is next.